Hello everyone, it's Daniel, Modern Identity Lead at Formula 5. In this video, I would like to talk about verifiable credentials, potential behind them, and also show you the concrete implementation, which is Microsoft Entra Verified ID. So let's start. As always, before practical demos, let's talk a little bit more about theory and some concepts. So let's start with centralized identity systems, because this is what we know that exists right now in the world. So in centralized identity systems, there is identity provider. It can be Microsoft Entra ID, can be Okta, can be Auth0, any other identity provider that controls the lifecycle and usage of credentials. And when I say credentials, it can be, for instance, username and password. And also in centralized identity systems, the identity provider holds user profile data. So we have to obviously create account first, provision account. Such account can have different attributes like first name, last name, city, country, age, and so on. And also this account has a set of credentials assigned. So users can then access different kinds of resources. So applications and services trust the central identity component, which is identity provider. So in this case, all those different kinds of resources, applications, services, and so on, trust identity provider. And before user can access such resources, user has to authenticate. Cool. So when we talk about centralized identity systems, obviously there are many advantages, but also there are some limitations. So organizations store vast amounts of personal data from users, which leaves users without control over who has access to their personal information. If we think about typical identity solution, there is always some kind of, registration form. If we talk about CIAM, Customer Identity and Access Management, there is registration page. And we collect different kinds of details about users. So we are collecting information about the user profile. And this information will eventually land in the identity provider side. And all other systems, obviously. When we talk about corporate world, situation is quite the same, yes? Because even if we start with HR system, we have to provide data about ourselves. And then this data eventually will be provisioned into identity provider like Microsoft Entra ID. So we will have user profile there. So as you can see, this information is collected in the centralized place, not managed by the user. There are limitations when it comes to trust boundary. So federations are required, which can take time and can be complex in managing. So when I say federation, is this mutual trust between different parties. Like there is organization A, there is organization B, and if we really want to trust, those accounts from another organization, we have to also build this trust relationship, which is called federation. And this can be also tricky in this case, and complex, obviously. Centralized identity systems introduce a single point of failure. So when you think about the disaster recovery, when you think about, situations where identity provider can be down, obviously the chance is low when it comes to Microsoft Entra ID, for instance, but still it exists. I mean, this limitation, this problem, because we store personal data in the centralized identity system, and if this system is down, then we cannot access all those different kinds of resources like applications. And there is one of the example from the past where Facebook was down. Probably you remember that, and users could not access their profiles, their messages and so on. So once they cannot authenticate, it means that they cannot move forward and they cannot access those different kinds of resources, features in the applications basically. And individuals are limited when it comes to share only what's necessary about their profile information. So when you think about typical authentication process nowadays, it's like, okay, do you want to share your profile information? Do you want to trust this application to access resources on your behalf? And if you agree, then you are passing the full information about your profile. So it cannot be like in the decentralized systems and verifiable credentials, which we will discuss in a minute, where we have selective disclosure. So it means that we can decide as a user which properties from our profile will be shared with third parties. So in this case, this is big limitation, because if we agree to share our profile, there is no chance to decide which attributes will be shared. And obviously we can think about some, custom implementations and so on. But if we talk about standards, this is how it is. Like there is my profile in the centralized identity provider, and I don't have any chance to decide which attributes of this profile will be shared. Okay, so now let's talk about decentralized identity systems. So those give individuals greater control over their personal information and digital interactions. And I want to underline one thing before we move forward. There is nothing really wrong in the concept of centralized identity system. Yes, it's been there for a long time, and that's perfectly fine. I'm not saying like let's drop centralized identity systems, let's switch to decentralized identity systems, because as you will see in this video, we can use both. But what I'm trying to say here is the fact that even if we have centralized identity systems right now, there can be scenarios where we need additional things like decentralized identity systems, and we can combine two, which we will see. Okay, so let's talk about decentralized identity systems. So in decentralized identity systems, control over the lifecycle and usage of the credentials is shared between three parties. So issuer, holder, and relying party consuming the credential. So when I say relying party, that's the application. The issuer is the organization or entity that is issuing some kind of credential, and the holder is the user which will receive this credential. And decentralized identity gives users and organizations greater control over their data, how that data is shared, and deliver a high degree of trust and security. So here, as we can see in the middle, there is Alice. Alice has her own verifiable credentials wallet. We will discuss those concepts in details, but there is Alice. Alice has her verifiable credential, her claims in this wallet, and this specific verifiable credential was issued by the Woodgroove on the left side, so the issuer, and on the right side, Alice can present this verifiable credential to one of the applications like Prosper, so the verifier, and those credentials or those claims inside verifiable credential can be verified. And obviously we will discuss this architecture in details, but this is like a simple concept to explain the centralized identity system. So there is issuer, holder, and relying party. Yeah, and all those things related to profile, like here for Alice, those attributes, those claims will land in Alice wallet. So on the Alice phone, for instance, in the Microsoft Authenticator app, we will see that in this video. So this information will not be stored by issuer and will not be stored by the verifier. That's the key here. Because you can ask like, hey Daniel, I don't see the difference between centralized identity system and decentralized identity system. In both cases, user has to authenticate in some way. We have to, provide some claims for the application, so application can authenticate user. So the main difference is that in centralized identity system, profile data will land on the identity provider side, and user does not have any chance to decide which profile data will be shared. And in the centralized identity concept, profile information is stored in the private wallet owned by the user, and user will decide when to share those claims, profile information, and which claims to share, which part of the profile user would like to share. Okay, perfect. Let's talk about some advantages of the centralized identity system. So identity holders have full control and ownership of their data enabled by the centralized identifiers. So globally unique identifiers and public key cryptography. That's very important. We will talk about the centralized identifiers, DID documents, but important thing is that the whole decentralized identity system concept is based on the public key infrastructure and public key cryptography. So we have private keys there, we have public keys there. We will describe those concepts, but it's very important to remember that yes, public key cryptography is used there. Users can selectively disclose only the necessary portion of their identity information, maintaining privacy and minimizing data exposure. And this is super crucial. So in this case, it's users' decision which portion of their identity information they want to share. And this is very important in centralized identity systems. That's different. Yes, there is one profile. If we decide to share this profile, all details will be shared about our profile. There are open standards and protocols promoting interoperability between identity systems and platforms. That's very important. So again, when we talk about the centralized identity systems, yes, there are also standards and protocols to make sure that those decentralized identity systems can talk to each other. It's not so simple, obviously, but still there are some standards and protocols, like in centralized identity world, like there is OpenID Connect, OAuth, and so on. So for decentralized identity systems, there are also standards and protocols. I want to underline one thing here, because I don't want you to, wrongly understand my intention. Centralized and decentralized identity systems can be both used together. So you will see in this video that we can use centralized identity system still for authentication, for instance. So user will have account in centralized identity system, but also user can have additional method of verification like verifiable credential to access the system. Or we can imagine the situation where we have user account in the centralized identity provider, and verifiable credential is used as MFA option, just to do the step-up authentication. So the case is that both can work together. That's super important to remember. Okay, so we talk about centralized identity system, decentralized identity systems. What about verifiable credentials? What are they? So let's talk a little bit more about verifiable credentials, concepts, and then we will slowly move forward to concrete implementation. So verifiable credentials are digital, cryptographically secure version of physical credentials. You can try to imagine like those, like credentials, physical credentials can be identity documents, academic achievements, licenses, certifications. Everything from the real world can be presented as a verifiable credential in the digital world. And with verifiable credentials, we can streamline identity verification, reduce fraud, and improve the efficiency of digital transactions. That's super important. So once we have such verifiable credential, we can really use it in many different kinds of scenarios. And yeah, it's very important to mention that with verifiable credentials, we can strengthen security and verification. That's one of the examples from that's one of the news from the recent time from CNN. As you can see, finance worker pays out 25 million after video call with deepfake chief financial officer. So just to really quickly explain what happened, there was a call, employee joined this call. Obviously on this call, there were different voices, deepfakes, and employee thought that he's talking to chief financial officer, and he heard other employees in the background. So he decided that, yeah, okay, I will proceed with this payout. And he paid out $25 million. So as you can see, this is a huge problem, like with identity verification and with identity confirmation. to make sure that I'm talking to the right person. And if you think about verifiable credentials here, which we will describe, with verifiable credentials, we can potentially avoid situations like this. So even if I had the call with Chief Financial Officer at Formula 5, for instance, before even I will do any transfer, I can ask in the system like, hey, do you confirm this payout? And Chief Financial Officer can use his or her verifiable credential, present it, and then confirm the transaction. So this is one of the examples. Or even, like after the call, I could ask this Chief Financial Officer to present his or her verifiable credential so I can be sure that I'm talking to the right and real person. So that's a huge problem right now in the identity space, as we can see, and especially when it comes to AI expansion right now. So those deepfakes will be broadly used. And this is also the space where verifiable credentials can be used. Okay, so now let's move forward with verifiable credentials and let's talk about standards. As you remember, I mentioned that in centralized identity systems, we have standards like OpenID Connect, we have OAuth, and so on. In case of decentralized identity systems and verifiable credentials, there are also standards defined. So for instance, there is verifiable credentials data model standard established by Wide Web Consortium, and this is the model for implementing verifiable credentials. And also there is OpenID for verifiable credentials. So OpenID for verifiable credentials presentations and verifications. So those standards are established by OpenID Foundation. So now let's talk a little bit more about the architecture in case of verifiable credentials and decentralized identity. So on the right side, you can see that there is this diagram and we have those parties here like issuer, holder, verifier, and there is also something what is called verifiable data registry. So this is the trust system. This is the place where, to make it simple, we are registering, we are storing the public keys responsible for data verification and verifying verifiable credentials, basically. So let's discuss those components here. So holder is a role an entity might perform by possessing one or more verifiable credentials and generating verifiable presentations from them. So in this case, holder is a user that holds different kinds of verifiable credentials in something what is called wallet. Wallet, you can try to imagine that wallet is an application like Microsoft Authenticator app in Microsoft Entra Verified ID world. And inside this application, we store verifiable credentials. Issuer is a role an entity performs by asserting claims about one or more subjects, creating a verifiable credential from those claims and transmitting the verifiable credential to a holder. So we have issuer, it can be entity, it can be, for instance, Formula 5 company, and this Formula 5 company has different claims related to user, and those claims are included in the verifiable credential that is issued to a holder, so to a user. So verifiable credential is issued and eventually it will land in the holder's wallet, so in the Microsoft Authenticator app, as we will see in this video. Subject, an entity about which claims are made. So typically subject is user, so we are basically providing claims about the specific user. Verifier is a role an entity performs by receiving one or more verifiable credentials, optionally inside a verifiable presentation for processing. So verifier will request presentation of verifiable credential from the holder. So before holder can access anything on the verifier side, holder has to present verifiable credential. And then verifier can look into the credential claims, can check the public key and who issued this verifiable credential, and verifier then makes a decision whether to accept it or reject it. And there is verifiable data registry, a role a system might perform by mediating the creation and verification of identifiers, keys, and other relevant data such as verifiable credential schemas, revocation registries, issuer public keys. To make it simple, verifiable data registry is a place where we store the information about issuers and verifiers. Yes, and also holders. So this is the place to which we can refer as verifier, for instance, and we can check who issued such verifiable credential. We can check the public key of such issuer, and we can decide whether we want to accept this verifiable credential or not. In such data, in the verifiable data registry, we can also look into the domain that is connected with specific issuer. So we can say, for instance, that, okay, this is verifiable credential issued by Formula 5. We can look into domain portion and we can see that, okay, this VC was issued by this organization which owns this domain and which has this public key registered in the verifiable data registry. And there is repository, so the wallet, a storage vault, personal verifiable credential wallet that stores and protects access to holders' verifiable credentials. Important fact is that all the claims information inside verifiable credentials, including verifiable credential, this will land in the holder's wallet. So user will own the data. It's not stored anywhere on the issuer, on verifier side. Holder has all information in his wallet. That's super important. Okay, so now moving forward, when it comes to concepts, there is decentralized identifier, so DID. And please note that sometimes people mistake this DID with decentralized identity. No, DID stands for decentralized identifier. A decentralized identifier is portable URI-based identifier, also known as DID, associated with an entity, like a company, like Formula 5. And this decentralized identifier has a specific format. So there is always scheme like DID. There is DID method. So DID method is basically the information how we can resolve specific identifier and resolve DID document, which I will explain in a minute. So there is DID method portion and DID method specific identifier. So below you can see the example from Microsoft Entra Verified ID. There is DID web method used, and then there is this DID method specific identifier to retrieve information about the DID document. So this is unique identifier, and with this unique identifier called decentralized identifier, I can retrieve the ID document. So these identifiers are often used in verifiable credential and are associated with subjects, issuers, and verifiers. So once I have such DID or decentralized identifier, I can retrieve DID document. So DID resolves to a DID document. And there is example of such document on the right side. And let's discuss the structure. So DID document contains the public key, the list of DNS web domains associated with DID, also known as linked domains, and information about other things like identity hubs and so on. I don't want to dive too much into this topic. The important fact is that once I have DID, so the decentralized identifier, I can retrieve DID document and look into DID document to check different things like, okay, to which domain this specific verifiable credential or this entity is linked. So we can see it's formula5.dev. And also what I can do, I can retrieve the public key of this entity. So inside the DID document, I have also information about the public key, which I can use to make sure that this specific verifiable credential was issued by this specific entity linked to this specific domain. So let's move forward and let's explain how does it work, because I feel that even if we talk about different parts of the decentralized identity and verifiable credential architecture, it can be still problematic to understand. So on the left side, we have Formula 5. This is the issuer, this is the company. And on the right side, we have Fabricam, another company, which is verifier. In the middle here, we have user. And this user has verifiable credential issued by Formula 5 organization. This verifiable credential confirms that this user is employee of Formula 5 organization. And now Fabricam can require this proof. So Fabricam can say, hey, before you can enter, before you can use our resources, please present proof of employment in form of verifiable credential. So what will user do during the presentation request done by Fabricam? User will decide whether to share verifiable credential or not. If user decide to share verifiable credential with Fabricam, Fabricam can look into verifiable credential and confirm that this user is really employee from Formula 5. Now, if we look what is happening underneath, this is very important. And this is where we have this public key cryptography, public key infrastructure. So each organization, like in this case Formula 5, which is issuer, record public key material in the public key infrastructure trust system. This trust system can be blockchain, but doesn't have to be blockchain. Please remember about it, because it's mistaken to think that verifiable credentials are purely about blockchain. No, this is not the case. We can utilize blockchain as a trust system for verifiable credentials, but we don't have to. With DID web, for instance, method and infrastructure, there is no blockchain. So that's super important. So underneath, that's why it's called trust system, because if we plan to, deploy such architecture and solution, we can make a choice how we will implement trust system. So Formula 5 recording public key material in the trust system here. So we can see that there is issuer, DID, example 123. It can be DID web Formula 5 tenant. And there is keys section. So public key is recorded in the trust system. So now when verifiable credential is issued to the user, we can see that this verifiable credential contains issuer, so the employer, Formula 5, the subject, so information about the user, in this case, claims, like this is the program manager, since when, and the issuer's digital signature. So verifiable credential is digitally signed. That's super important. This verifiable credential lands in the wallet, in the user's wallet. And right now, when user will present this verifiable credential to Fabricam, what Fabricam will do, Fabricam will look into the issuer section of this verifiable credential. So there is this DID example employer, which will be Formula 5, the centralized identifier. Fabricam will then check the DID document and extract the public key information. And what Fabricam will do, Fabricam will verify issuer's digital signature, but also it will verify subject's digital signature in the verifiable credential. So when user is presenting this verifiable credential to the Fabricam, this verifiable credential has not only the digital signature from the issuer, which is Formula 5, but also has subject's digital signature. So it's signed by the user's wallet before it's presented. And Fabricam can look into the data in verifiable credential, can check the digital signatures, can check the claims, can check the issuer, can check the domain information like formula5.com or formula5.dev. And then Fabricam decides to either accept credential or to reject it. So this is the concept here. So this is about the decentralized identity and verifiable credentials. First of all, why decentralized identity here? Because we have this trust system, as we can see. There is no federation, yeah? If we decide to use this system, we can integrate with this trust system and we can verify those digital signatures. So obviously we have to comply to specific standards and implementation approach, but this is the case here. So on the trust system, so this is what we see below. No user data lands, so it's another very important aspect. Those claims from verifiable credentials or even verifiable credentials will not land on blockchain or in any other place. That's very important to underline. Verifiable credentials, claims included in verifiable credentials, will purely land in the user's wallet. In the trust system, which is publicly available, will only have information about the issuer, about verifier, their public keys, but no private keys will land there, no user claims will land there, and so on. So that's super important. And another aspect is that the data about the user profile lands in the user's wallet. And then user will decide whether to share this data in form of verifiable credentials or not. Okay, perfect. So right now let's discuss some use cases. So how verifiable credentials can be used in the real world scenarios. Let me start with a typical scenario and then I will provide more. But let me start with self-service account recovery. So probably you are aware of, like support calls. So to basically in a typical situation, if something happened in the company, let's say like I cannot log in, I cannot access specific resource, I cannot do this, I cannot do that, then I have to contact support team. And obviously when I contact support team, it's hello, it's Daniel, oh hello, it's XYZ from support team. I need to verify your identity right now. So, like they will either send some code and you have to provide this code. Probably you will have to answer a few questions asked by them and so on. This can take time and this can be complex. So to reduce support phone calls and security questions with a simpler and more secure process to verify identity, we can use verifiable credentials. So once we want to, let's say, retrieve access to our account again, there is the first step, verify my identity. So we click begin verification and there is presentation request like, hey, we would like to check your verifiable credential issued by ID verification company XYZ. Once we have this permission request, we allow to share this verifiable credential. And once we share it, in the step 2, we can reset our password, for instance. So instead of, calling support team, instead of presenting some codes from text messages, answering some questions, we can just go through verifiable credentials and we can present credential and then we can change our password. There are more use cases for verifiable credentials. Let me talk a little bit more about use cases in healthcare. So there is enhanced security when accessing patient data when we use verifiable credentials. So before data can be accessed, authenticated user must present verifiable credential to confirm identity. So in a typical scenario, you can try to imagine that there is patient portal and it's secured by identity provider. So again, we talk about centralized identity system. User provides username and password. And after that, once user can access patient portal, there is a specific section. Let's say that potentially some, information about the surgery or some specific medicaments. So once user can access it, or prescriptions, let's say, once user can access it, this section and this data, user has to also present verifiable credential to confirm identity. And then data is displayed to the user. Storing insurance information. So users can hold their insurance certificate in form of verifiable credentials. So again, instead of keeping some paper certificates, tons of papers and so on, we can just have our wallet, our application, we can have verifiable credential there, and inside verifiable credential in form of claims, we can have information about our insurance certificate. Vaccine records can be stored in form of verifiable credential with expiry date. Yes, so we all remember the COVID time, unfortunately, and we remember those COVID passports. We had to show the paper that we were vaccinated and so on. Sometimes it was automated and presented in a digital way. But anyway, like in verifiable credentials world, we can simply implement such scenarios. So once we are vaccinated, we can get verifiable credential that will confirm that yes, we did it. Digital prescriptions. So in a typical world, we got those prescriptions from doctors in a paper form, or there is just a system where we have to, we will receive the code. We have to provide our personal ID number along with this code, and then we will get medicaments. But in the world of verifiable credentials, we can receive and use prescriptions in form of verifiable credentials. So you can try to imagine the situation that once you got this prescription in form of verifiable credential, it will land into your wallet. Then you will go to the shop, you will present this verifiable credential without talking loudly in this place about your personal data. And then this will display to the pharmacist the information that, oh, okay, those medicaments were recommended, so I know what to do. This is about the healthcare, but there are also some use cases in the insurance industry. Proof of insurance. So verifiable credentials can be issued to policyholders as a proof of insurance coverage. So again, simple as that. We have our insurance proof in form of verifiable credential in our wallet, and we can present it to the policyholders, to the verifiers, basically. Customer onboarding and KYC, know your customer compliance. So verifiable credentials can streamline the customer onboarding process by enabling issuers to verify the identity and background of prospective policyholders more effectively. And we know that this is not only about the insurance, it's also about banking industry. I mean, like know your customer. So we can use verifiable credentials during the customer onboarding process to make sure that customers in the future can present those verifiable credentials and confirm their identity. Credential verification for service providers. So verifiable credentials can be used to verify the credentials and qualifications of service providers like auto repair shops, medical facilities, ensuring the policyholders receive high quality services. So instead of presenting some papers to those organizations like auto repair shops, we can simply show a verifiable credential, and then we can proceed to repair our car, for instance. Credential-based access control. So verifiable credentials can be used to control access to sensitive information and systems within insurance companies. Yeah. So similar situation to the patient portal I mentioned before in the healthcare industry. So even if we are authenticated, even if we have access to the application, still we can add this additional level of security. So if user wants to access specific section, functionality, data, user will have to present verifiable credential. Okay, perfect. So this is about the concepts and about standards and differences between the centralized and centralized world. But now, let's talk about concrete implementation. So obviously on the market you will see few implementations for verifiable credentials, but from our perspective in this video, it's important to mention that there is dedicated service in the Azure cloud under Microsoft Entra umbrella that supports implementation of verifiable credentials, which is Microsoft Entra Verified ID. It's Microsoft's implementation for verifiable credentials. So we can use Microsoft Entra ID to issue and verify credentials that are generated basically and issued to the users. So let's talk about Microsoft Entra Verified ID. So first of all, it's worth to mention that there is management interface in the Microsoft Entra Admin Center. So when we open Microsoft Entra Admin Center, on the left side, there is Verified ID section. We can get started. We can configure this service. We can get our employee credential. We can register custom credentials there. We can customize the look and feel, as you can see. So we can add the logo. We can change the font color. We can change the background color. We can decide which claims will be included in the verifiable credentials. With Verified ID, we also have Microsoft Authenticator app, which is end user wallet. So all those verifiable credentials that will be issued using Microsoft Entra Verified ID will land in the Microsoft Authenticator app. And there are also developer tools and APIs. So obviously we can use the portal for simple operations, but there is also a set of great developer tools and APIs so we can integrate our applications and solutions with Microsoft Entra Verified ID. I want to talk about trust system in Microsoft Entra Verified ID. So the trust system is responsible for maintaining the verification system for verifiable credentials. This is what I mentioned before, as you remember, yeah? So this is the place where all those things like public keys, DID documents land, and so on and so on. So important fact is that to some point in the past, there were two potential trust systems supported. So DID Ion, so Decentralized Identifier Network, that runs atop of Bitcoin blockchain. So yes, Bitcoin blockchain was used there, but also there is DID Web, so system that allows trust using a web domain's existing reputation. And there is no blockchain used here. That's super important to mention that. So DID Ion is using blockchain, DID Web is not using any blockchain at all. And with recent updates, DID Ion method and trust system, basically Ion, is not supported anymore. So the only method that is available in the Microsoft Entra Verified ID is DID Web. So we will have decentralized identifier in more understandable, presented in a more understandable way for users, and those DID documents will be retrieved using those DID identifiers. Yeah. So in this specific case, when we create the verified ID service, we configure it, DID Web is the only option. So no blockchain here anymore, just to confirm. Okay, perfect. So right now I would like to do a short overview of Microsoft Entra Verified ID. I would like to show you some basic functionality, employee credential, and basically I would like to show you how it works. So let's start. Here is Microsoft Entra Admin Center, and from the left side I selected Verified ID section. And here is the Get Started section. I've already configured my Verified ID service here, but if you are doing this first time, you will have different options. If you have linked domain with your Microsoft Entra ID tenant, you can use Quick Start approach, and the service will be provisioned for you, and you can quickly start issuing and verifying credentials. But if you do not have any domain linked to your Microsoft Entra ID tenant, then you have to go through a little bit more manual steps. Everything can be found in the official documentation for Microsoft Entra Verified ID. Perfect. So right now, under the overview section, we can see that here is the basic information about the organization name, so Formula 5. There is domain linked with this verified ID, so formula5.com, it's verified. And we can see that there is verified employee credential for Formula 5. And now if I switch to credentials, you will see that there is verified employee credential, which is here for customization every time you create verified ID service. But also you can click add a credential, and then you can create custom credential for any purpose. And this is what we will see in the next demo with Formula Health demo. So if I get back to credentials and I will select verified employee, here we can see the details. We can see 8 claims that will be included in this verifiable credential. So display name, given name, job title, mail, and photo. So we can also include photos in verifiable credentials. Here is the manifest that will be used by Microsoft Authenticator app to display this nice card. So this will load information about the claims, about the logo, about the colors, and so on. And when we click issue a credential, this is the place where we can move forward with the issuance. So obviously We can implement the issuance process on our website. So here is the post API call and request body we can use. But we can also issue this credential through my account portal. So here, if we select issue credentials through my account portal, then we have chance to issue verifiable credential to user from our organization in the my account portal. And here we can decide who can retrieve a credential. So all Microsoft Entra ID users or only specific selected groups. So this is really, really powerful. And at the moment of recording this video, this is in preview, but probably when this will go live, it will not change very. So let's look at this. When I switch to my account portal, here is my account, and here I can select get my verified ID. And now, once I click it, the QR code is generated, and I will have to scan this QR code with my Authenticator app. And this QR code is valid for 5 minutes. So now let's see what is happening on the Microsoft Authenticator side. So on the left side, there is screen mirroring from my phone, and this is Microsoft Authenticator app. Right now I'm clicking QR code icon, and I will scan the QR code. And right now I have to accept this verified ID. So as we can see, there is a verified employee displayed here, and we can add it to our wallet. So when I click add, it will land in my Microsoft Authenticator app. So here is my verified employee verifiable credential. And if I open it, you can see that it was issued for myself. So this verifiable credential is issued to all members of the Formula 5 org. There is my first name, last name, my email, my job title. And also, as you can see, if I scroll down, we can see the user picture and issued by Formula 5. So with such verified employee right now, I can move forward and proceed with additional verifications in the future. So for instance, if my help desk will require from me to present verifiable credential like this, I will be able to present it. So let's see such scenario. Here is the Woodgroove help desk portal. This is the demo application. First of all, to contact support, we have to provide verified ID card with photo. And from there, I will click I already have my card, and I will scan the QR code to present my verified employee card. So now let's see what is happening on my phone. On the left side, we can see screen mirroring from my phone, and I will click QR code icon, and I will scan the code. And right now, there is a question. Do you want to share with Woodgroove Help Desk? And you will share verified employee, verifiable credential. And additionally, there is result of the face check, as you can see. And this is currently in the public preview, as I mentioned, at the moment of recording this video. So during the presentation of my verifiable credential, I have to scan my face to make sure that my face matches the photo that is included in this verified employee verifiable credential. So if I click verified employee, this is my verifiable credential. And as I mentioned, here is my picture. And now if I get back here, I have to also present my face. So I will have to click result of the face check. So I will do it now. And there is information that whether I want to start the face check. So I will click start. And right now, it's scanning my face. As you can see, I have to move closer. And now the face check is done. And once it's completed, and it matches the specific threshold, which is set in the presentation request, now I can share it with Woodgroove. And once it's shared with Woodgroove, Woodgroove is confirming my identity, and then I can get support. And as we can see, those are my claims like email, name, and also the face check score. So 90%. So as you can see, quite high. And obviously, we can modify this threshold. Okay, perfect. So this is about the employee verifiable credentials. So right now, let's get back to the presentation. I would like to also refer to one question about verifiable credentials. This is also super important. What about trust and claims verification? Because right now we discuss verifiable credentials, we talk about claims inside those credentials, yes, but there is still a question. How we can validate claims that will land in those verifiable credentials? How can I trust those claims presented in form of verifiable credentials? So there is something what is called identity proofing, identity verification. So identity proofing, also known as identity verification or IDV, is the process of verifying that individual is who they claim to be. Before verifiable credential is issued, there should be verification done to confirm authenticity of all the claims. That's very important. So, simple situation, like for instance, during the onboarding, when we onboard new employee, once employee presented some documents, some ID, we had personal meeting, we can then register this information in the HR system and we can generate verifiable credential for such user. Or, for instance, in the car rental company, once user presented driving license and ID card, then we can generate verifiable credential with this data. And next time user wants to rent the car, user will present verifiable credential instead of physical documents. So that's very important that we still have to verify what will land in the verifiable credential in form of claims. And here, let's talk about simple example of identity proofing. Yeah. So here we have Jane. Yeah. And Jane is a person and she would like to rent a car. So first time she's visiting car rental company, she has to present driving license. So this is the physical document. And once this driving license is verified, is confirmed, then Jane will receive verifiable credential. And the next time Jane wants to rent a car, she will present verifiable credential. That's one of the examples, but still it's very important to validate, verify those claims that will land in the verifiable credentials. So it's about the trust here. So obviously, we cannot say that if someone is presenting verifiable credential, that's the proof. Because this person has verifiable credential, there are some claims inside this verifiable credential, yes, we can trust this person. No, we have to, make sure that this verifiable credential was issued by the real institution, those claims were verified, and we trust the issuer, basically. There are many identity verification services on the market. Yeah. So as I mentioned, obviously there can be physical identity verification, and this can be in person, like we have conversation with person, we are verifying documents, and then we generate verifiable credential. But there are also identity verification services which can do it for us right now. So it's on FIDO, LexisNexis, Jumio, Clear. So those are the services responsible for implementing identity verification, especially in the online world. And yeah, that's very important to mention that in the era of AI and deepfakes, this can be even more challenging to confirm identity remotely, but we will see. Anyway, with those services, you can implement identity proofing and then generate verifiable credentials. Perfect. So right now, I would like to present Formula Healthcare demo. So this demo is more focused on the customer world, so external world basically. And here we have the patient portal, Formula Health, and patients can access this portal. They can register first using Azure AD B2C. They can create their accounts, and once they are authenticated, they access a patient portal, they can get verifiable credential. And once this verifiable credential is generated, next time patients can use verifiable credential instead of username and password to authenticate. And obviously, in the future, you could try to imagine that in the real world scenario, once we have verifiable credential inside the application, when we want to access specific medical data, we have to also present verifiable credential that was issued by Formula Health. And also in this demo, I would like to show you the cool feature, which is face check. So during the verifiable credential presentation, we have to also do the face check of the person who is presenting such verifiable credential. So let's jump in. In the previous demo, we saw usage of verifiable credentials in the corporate world. In this demo, I would like to focus on the B2C or customer world. So this is Formula Healthcare Patient Portal. This portal is secure with Azure AD B2C. In this demo, we will see usage of both systems, so decentralized identity systems and centralized ones. Because in this context, Azure AD B2C is centralized identity system, which is just identity provider. So the portal is secure with Azure AD B2C. So each user has to create an account first and then use username and password to sign in, or other methods like Google or LinkedIn. And now we will see how to also access this portal using verifiable credentials. So here I've already created an account. So I will provide my email, I will provide the password, I will click sign in button. And right now, once I'm successfully authenticated, I can access the portal. And here is the information. Congratulations, you have just used Azure AD B2C for authentication. Now click the button on the left to get your patient verifiable credential. So I will click got it. And here is the information. Use your patient verifiable credential to log in faster. Next time on the login page, select verified patient login and scan the code with Microsoft Authenticator app. And I will select got it. This is a simple demo, but in a real-world scenario, you could also use verifiable credential to access specific sections in this portal. Like for instance, to generate a report or write a prescription, anything. So this will be additional layer of verification in this specific scenario. So from the left side, I will click get your credential. And now, as we can see, there is the QR code displayed. Let me minimize it. So we can see that there is QR code and there is also the PIN displayed. And we will have to provide this PIN during the issuance process. So now let me show you what is happening on my phone. On the left side, we can see screen mirroring from my phone. So again, I have to click QR code icon and I will scan the code. Once the code is scanned, we can see on the left side that we have to provide this verification code. So we will need this to claim the Formula Healthcare Verified ID. So I will provide it 7458, and then there is information that the verified patient verifiable credential issued by Formula Healthcare will be added to my wallet. And obviously at the top you can see that there is formula5.dev. This is the dev environment, but the case is that the domain is linked to this verified ID. So I can check that, okay, this verified ID is really handled, issued and generated by Formula 5 organization. So I will click add button, and right now this verifiable credential will land in my wallet, which is Microsoft Authenticator app. We can see in the app that there was confirmation that verifiable credential was successfully issued. Now, when I open this credential, you can see that here, there is my national healthcare ID, full name, patient ID, and there is also user picture and Formula Healthcare information, like this was issued by Formula Healthcare. Perfect. So right now, let me sign out from the application. So I will sign out. And right now, I will click Verified Patient Login instead of providing credentials like username and password. So I click this button, the QR code is displayed, and right now I will scan this QR code. And right now there is presentation request, so I will have to provide my verifiable credential to confirm my identity. Again, as we can see, there is face check required. So I will click face check, I will click start button, and right now I have to scan my face. I have to do the face check. Once it's done, once my identity is confirmed and the face threshold is accepted, then I can click share button. So in this case, I'm sharing my verifiable credential with the patient portal. I was successfully validated, and right now I can successfully access patient portal in a more secure way. So after a few seconds, my information is verified, and I will be successfully redirected to the patient portal. So here, as you can see, I'm successfully authenticated. Here is my picture, first name, last name, patient ID, and so on. And this is the scenario where we can really improve the security. Instead of using username and password, we can use verifiable credential to access this patient portal. Inside the patient portal, we can access different sections, and before accessing them, we can require to present verifiable credential. And what is more important even is the fact that during the presentation of verifiable credential, there is this face check done. So we are verifying, the service is verifying my face during the presentation to make sure that the person that was issued this verifiable credential is really the person who is presenting this verifiable credential. And once everything is verified, then we can successfully access patient portal. The last thing I want to show is custom credential definition in Microsoft Entra Admin Center. So under credentials, we can see that I created verified patient credential, and the type is custom type. So let's open its definition, and here is the credential preview. So we see this verified patient credential. Organization is Formula 5 Dev, this is dev environment, and also the dev domain is linked to this specific service and this verifiable credential. Under the claims, I have 4 claims that are defined and will be included in this verified patient verifiable credential. So full name, national healthcare ID, object ID, and photo. So those 4 claims will be included in the verifiable credential. Here is the manifest URL again, so Microsoft Authenticator can render this verifiable credential properly. And under the properties, when we will click it, you can see that here is the display definition and rules definition section. Display definition is the place where I can define how this card will be presented in the Authenticator app and what will be included, like who issued this, description, text color, title, logo, and also information about the claims here, as you can see. And under rules definition, I have to provide information about the claims. So in this case, as you can see under attestations, I'm providing information that this will be ID token hint attestation. So I want to include specific claims in this credential in a custom way. It's more advanced implementation with Azure AD B2C, but the important fact is that here I'm providing the mapping for all the claims. So full name, national healthcare ID, object ID, photo, and also what we can see here, there is this verified patient type for verifiable credential. So perfect. And right now, when I'm presenting this verifiable credential, when the presentation request is done, inside the application, then I'm requiring to do the face check additionally. So the portal has this requirement that you have to provide verifiable credential, but also confirm this verifiable credential doing the face check. Perfect. So that's it about verified patient verifiable credential. Thank you so much for watching this video. I hope you found this interesting and helpful. I really encourage you to check Microsoft Entra Verified ID service. If you would like to learn more about identity topics, I invite you to visit our insights blog under formula5.com. And I would like to also mention that if you need any help with Microsoft Entra Verified ID implementation, we as Formula 5, we are a verified services and solution partner. So you can find us under this link, and we are responsible for providing different kinds of implementations leveraging Microsoft Entra Verified ID and Verifiable Credentials. And obviously, if you have any other questions, you can contact me using the email presented on this slide. Perfect. So thank you so much again, and see you in the next videos.